In this example, we have been asked to use a graphing calculator to estimate the real zeros and the relative maxima and minima for this particular polynomial function. Now first notice that this polynomial is not in descending order. However, if you're using a graphing calculator, it does not matter if it's in descending order or not. Now, I am actually going to ask you to write it in descending order because you know something about the function when you write it that way, and then you're going to know if you're getting the right thing from your calculator or not. So in this situation, the highest degree is 5, and so I would want to write that particular term first, and the next highest is the x squared, and then finally I have the 12x. The reason I'm saying that is here you can tell that the leading term is negative x to the 5th. It has an odd power, so you're expecting the ends to go in opposite directions. Because the front sign is negative, then you're expecting the left-hand side to go up. So let's go type this in on our calculator first of all. So go to y equals, press negative x raised to the 5th power. I have to arrow over, plus x raised to the 2nd, arrow over, and then plus 12x. Okay, now in this particular problem we don't really have any idea of what to set our window to, so if that's the case, just do a zoom and then a standard to start, and then we can make adjustments if we need to from there. We look at this one and we see when we graph it that for sure we have the right side top of our graph cut off, and then we see that the left side is just barely low enough. Now we also see that we have a lot of extra space on our x-axis. So let's go back and let's make a couple of adjustments. So go to your window, and let's say first of all that we take these x-max and x-mins down a little bit. So let's say we go from negative 5 to 5. And then on the y's, let's increase those actually. Let's go from, let's say, negative 20 to 20. I think that will give us a better idea of what our graph ought to look like. Press graph, and then that's a much better picture. So what I would want you to do first of all is just to sketch this for me on your paper. This doesn't have to be perfect, but I do want a few details. You see here that it looks like my graph goes actually through the origin, back up and down. Now notice your end behavior is what you were expecting. The left-hand side goes up and the right-hand side goes down. On your graph, I'd like you to label so that I know what you used for your window. We went from 5 to negative 5 on the x's, and then from 20 to negative 20 on the y's. Okay, now here they're asking us to find several different things, and I'd actually like you to do them each separately so you don't have them mixed up. Let's first focus on finding zeros. The zeros are where your graph crosses the x-axis, and so these are the values that we want to find. Notice that it looks like the graph crosses actually at 0, 0. However, don't assume that until you've actually found it from your graphing calculator. Now your calculator can only find one zero at a time, so you're going to have to do this 3 separate times. So we're going to press second, trace, go down to 0, press enter. Let's say that we want to find the far left one. So it's asking for a left bound, so arrow over. That would be about the point we're actually trying to find, so we need to arrow a little bit to the left of that, press enter. And then arrow now to the right. Make sure you go over that point a little bit to the right. Press enter. And when it asks for a guess, press enter again. All right, let's round these off to 1 decimal place. So that particular ordered pair would end up being, and I'm going to kind of pull it out here so we can see, negative 1.8 if we round, and 0. Now we have to go back and do the same process for the 0 we have here. So do second, trace, 0. Okay, we're looking for this one. So we actually here need to arrow to the right. Stop just a little bit to the left, press enter, And then when it asks for a write down, make sure you go up and through that actual point you're looking for until you're a little bit to the right, press enter, and then press enter again. On this one, our suspicion that was actually 0, 0 was correct, so we'll label that 0, 0. And then finally, we need to find the 0 here. So do second, trace, 0, enter. We need to go to the left. In this case, we actually need to arrow right to get over there close to it. Somewhere in here, we'd be just a little bit to the left of what we want to find. Press enter, and then arrow right. Make sure you go over and below it in this case. Press enter, and then guess, press enter again. That 0 looks like the ordered pair. If we round to the tenths, it would be 1.9, comma 0. Okay, now on here they were asking for the real zeros. The zeros are the x values off of those ordered pairs. So let's go ahead and write that information down. So the zeros are x equals negative 1.8, x equals 0, and x equals 1.9. Now we need to find the relative maximum and minimums. Those points would occur here and here. Once again, we have to do them separate on the calculator. So press second, trace. Let's say we want to do the minimum first. Go down to that one, press enter. The minimum is this one here, so we need to make sure to arrow to the left of that particular value. Okay, we want to make sure to kind of get out of the dip a little bit to the left, press enter, and then go to the right, make sure to get out of the dip, press enter, and then enter again when it asks for a guess. Okay, at that particular point, let me pull it out so we can see it a little better, is, if we round to the nearest tenth, it would be negative 1.2, comma, negative 10.5 if we round. And then go through and find the maximum here. So second, trace, maximum, press enter. We have to arrow over so that we're just a little bit to the left of that particular value. Press enter. Keep arrowing past it to the right. Press enter. And then when it asks for a guess, press enter again. That ordered pair appears to be 1.3 if we round, and then 13.6. Alright, now on here, my relative maximum and minimums are always y values. So my relative minimum, in this case, would be y equals the y value from that point, so negative 10.5. The relative maximum would be the y value from this point, so y equals 13.6. Okay, so we have graphed, and then we have answered their two questions about zeros and maximums and minimums. The range of this function we can see by looking at the graph would be negative infinity to infinity.